Yo, what's up, guys? Welcome back. We're gonna do a little quick video here. I just kind of go back about an hour ago, so I kind of settled in. I, have been gone for about 4 or 5 days, so I definitely wanted to make a video. Tomorrow will definitely be a longer video. Probably, like what we usually do, probably around 2 hours, but I just wanted to pump out a question here and pretty much call it a day. Wake up tomorrow with kind of like a fresh mindset and, get back at it. So, that's the goal. So, yeah, had a good weekend up in Chicago. It was my girlfriend's birthday, so, it was very fun. Went and saw some friends for graduation at my old school. And yeah, we're back to continue the grind, and I'm excited for that. So let's jump in. I believe we're at episode 115 today, so we got a Kangaskhan. Let's take a look at the sound. It's kind of like the kangaroo, man. Left foot, right foot, left foot, right foot, left foot, right foot. Like a dinosaur, man. Ooh. There's my sound right there. Let's jump straight into a problem. You'll probably notice that the screen is kind of reddish. I kind of added this nighttime effect and not get the strain on my eyes. I definitely need to get some blue light glasses. I hate having the light on in my room, dude. I like working in the dark. I'm kind of a vampire, but that's what I like. We got a hard problem here today. Maybe we can take a look at some of the recent problems because we did miss a few days. I did take a look at one of the problems one day. 3 consecutive ones. This is the one I did. Finding 3-digit even numbers. How about we just take a look at this one, and then we'll call it, just an easy problem. Kind of warm us up into tomorrow, and then we'll call it. So let's take a look. You give an integer array digits where each element is a digit. The array may contain duplicates. You may need to find all unique integers that follow the given requirements. The integer consists of a concatenation of 3 elements from digits in any arbitrary order. The integer consists of a concatenation of 3 elements from digits in any arbitrary order. Okay. The integer does not have leading zeros. The integer is even. For example, if given digits were 1, 2, 3, integers 1, 3, 2, and 3, 1, 2 follow the requirements. Okay. Return a sorted array of the unique integers. I'm trying to think what the best way is. 210, 230. So my initial thought of this problem is to kind of solve it a backtracking way. That's kind of the way I'm thinking about it. But since this is an easy problem, I don't think the solution that we're looking for is really that. Take a look at the hint. The range of possible answers include all even numbers from 100 to 99 inclusive. Can you check each possible answer to see if it could be formed from the digits in the array? Damn, I didn't think about that. So I guess we could solve it a backtracking way, but we could also solve it that way because I didn't think about that. Finding 3-digit even numbers. How can we do that? Well, we'd have to use some sort of loop that counts. right? All the way to 999. I guess we can do that, like, while num is less than 1,000. This seems kind of weird doing this. We'll make num equal to 0, right? Maybe we can return a sorted array of the unique integers. We do have duplicates in here. Maybe I was thinking a set here, but now I'm kind of thinking probably more of a hash map here. Alright, because when we can store the key value pairs, so we can do. Let's actually. Hang on. Import counter Python. We need a counter object. Let's do this. Man, I'm not used to the speed of my mouse here. You have to turn it down a little bit. Okay, this is hella slow, dude. This is probably a little faster, but because this is kind of a bit too quick for me, you know? It's like this is way too slow, dude. Again, way too fast, slow. This is probably the one. Okay, this is probably have to get used to. This is a little bit slow, but I feel like, but I don't know. Maybe we can mess with the DI settings later. But okay, let's do. Shit, how do they do in the documentation here? We do counter. Let's do. Is it counter digits? Is this how we do it? Print my dictionary. Let's copy this. Does this print in? Okay, counter digits 2, 1, 3, 0, 1. Okay. Okay, so we can do. Okay, well, while num is less than 1,000, right? How can we do this? We can technically, like. Num string is equal to num. Let's do string num. I think we'll have to convert this to a string. Maybe we can do like a helper function here. Let's do check numbers. Sorry. Let's do def check numbers. And we pass in. Let's just do num, right? We pass in num and we can do. Okay, well. Actually, let's pass in my dictionary too. Let's go dictionary. Let's do. Okay, well. For I in num, if I in my dictionary man, I feel a little rusty. I haven't been here for a little bit. Oh, shit, man, we got a lot to update. Okay. If I in my dictionary for I in range length num, right? If nums, we might need the index. I don't know. If nums I in my dictionary, then let's do, well, minus core dictionary. We have to check if nums I is in my dictionary. And I guess we have to check if nums, okay, if minus core dictionary nums I is greater than 1. It's greater than or equal to 1. Right, then we know that that's a valid number, right? So let's do minus core dictionary nums I minus or equal to 1. Then we can check, well, if minus core dictionary nums I is equal to 0, then we can delete minus core dictionary nums I. Right? I think that's how it works. When we go through this for loop, then I think we're gonna have to call. Do we actually want to delete it though? That's the thing. I don't think we need to delete it because technically we can just like I don't know. I don't think we really have any time constraints here. I think it's going to run even with like a super slow solution. So maybe we can just delete it anyway. And then after the for loop, we can reinitialize it. Minus core dictionary is equal to counter digits. All right. Then we want to call, well, check numbers, and then pass in num string, right? Okay, let's do like an else here. Then we can, else we just return false, right? Otherwise, I guess we can return true, right? Then we can check, well, if check numbers string num string, right? So if it's true, then we can check, well, okay, well, if we're only checking 3-digit numbers, right? So num string, right? And then we check, well, if the length of num string is equal to 3, right? And let's do this one last. Actually, let's see. Okay, if the length of num string is equal to 3 and num %2 is equal to 0, then we can call check numbers, right? And then if this returns true, we have our number. What are we returning? A list. We can add it to our list. We can do reds dot append num, right? Reds dot append num. All right, and then we can return our reds here, right? So we're gonna need some sort of res array. Okay. We have our check numbers function, helper function. We loop through every single number. I guess technically we can start from 100, right? Like, we're gonna have to start from 0. It's just a waste. We don't even have to check if the length is 3, because we always know that the length is 3 starting from 100, so... If num%2 and check numbers, I don't want a nested for loop, I just want... Right, then we can return res. Meaning, if it's even... Nums is not defined. Oh, bro, it's digits, dude. Digits I. Cloud saving, dude. I'm looking for nums, bro. Digits. Num string. Okay, let's take a look. Oh shit, we're not increasing num. Whoops. Num plus equal 1. How many times is this printing, bro? Okay, it's printing all the numbers, right? Up to 999. Okay. So what is this doing? If num%2 does it get in here? Print I. Let's get rid of this. Does it get in here? 0, 1, 2. Why is this not printing? Oh, where you going? Okay, totally forgot we can do this, low key. Just go for num in range 100 to 1000. Totally forgot about that. Makes it look cleaner. If num%2 is equal to 0, right? I guess then we can call numString, right? Then we can call, this is just makes it look better, I guess. Doing the same thing, right? Then we don't need this because we don't have a while loop anymore. So let's get rid of that. Okay, we do a counter, we do a res, we do temp counter. This is what I was gonna do. Compare two counters, dude. Digit counter, counter digits, right? Then we get rid of this, right? And we just pass in our num string, right? And then instead, when we loop through the num, we create, call it cur counter, is equal to counter, let's do num, right? Do some list comprehension here in Python. We do int d for d in num string, right? For I in range length num. So we compare both the counters. We can kind of get rid of this, right? So really, when we're comparing, we can do, well, for I guess for key value, right? In cur underscore counter dot what is it? Is it dot dot items, dude, that's it. Right? Then we can compare, well, we can check if cur dot items dot values dot keys Python. Items, values, keys, you said. Whoops. For key value and current items, we can check, well, if you just do, well, if value is greater than we have to loop through the other one, right? If digit counter digit if let's do digit counter, this cur counter. I hate underscores, man. Digit counter, right? And we go, we can get rid of this. We don't have to redefine it anymore. If digit counter key is greater than value, right? Then we can return false. We're comparing here. Otherwise, we can return true. And I think this should pass. Cur counter is not defined. Oh. Cur counter. Holy shit, dude. Sorry, less than value, not fucking greater than value. Jeez. Okay. I think that should be good. See if that submits. Nice. Oh, wow. And that's the fastest way to do it. Interesting. Well, thought of the fastest way to do it, so that's good. Enumeration with images. So you got a Python 3 solution. Please upvote me. Nice. We're gonna leave it at that. Again, just a quick little video. I didn't wanna not make a video today. I was thinking about it, but I just wanted to get back into it. I was kind of fiending to solve a problem. So, but yeah, I appreciate you guys watching. And I will see you tomorrow for a longer video. We'll have some more fun tomorrow. So appreciate you watching. See you tomorrow.